All right, today we're tackling a really powerful new design principle for building advanced AI systems. It's called Meta-Agentic Bootstrapping. Yeah, it's a bit of a mouthful, I know, but trust me, it represents a huge shift in how we should think about engineering AI.
So let's get right into it. We all know that large language models are amazing at conversation. They can talk about almost anything. But getting them to be reliable builders, to create complex working software, that's a whole different ballgame. The real puzzle has been, how do you get an AI to not just try to build something, but to systematically test its own work, fail, and then correct itself until the job is done perfectly? Well, the answer seems to lie in a totally new kind of AI blueprint. Instead of just handing a language model some tools and saying go, this approach builds an entire structured world for the AI to operate in. And it really comes down to two main parts. First up, you have what's called the domain-specific scaffold. The best way to think about this is like a glowing digital architectural plan. This is the boss, the governance layer. It sets all the rules of the game. It defines exactly what a successful project looks like, the blueprints for all the digital parts or artifacts that need to be built, and all the quality checks they absolutely have to pass. Okay, so you have the architectural plan. Now, right there in the middle, at the very center of it all, is the inner coding agent. Now, this is not just some simple tool. This is an already skilled and capable AI. Think of it as a pulsing, energetic core whose one job is to do the actual work. It's the one creating the files, writing the tests, and fixing the code, all inside the little world that the scaffold has defined for it. So you've got the architect, the scaffold, and the master craftsperson, the inner agent. How do they actually work together? Well, this is where it gets really cool. Together, they form this incredibly powerful, self-correcting engine. Let's take a look at exactly how that engine runs. And this diagram just illustrates the whole thing perfectly. You can see the user's task comes in at the top, into that governance layer, which then sets up the entire artifact world. The inner coding agent down below gets to work, but, and this is the crucial part, everything it creates is constantly being checked by validators and tests. Any little failure sends an error signal right back to the agent so it can fix it. This process creates this super tight, recursive loop. It goes like this. The agent builds something. An external validator, picture it like a scanning beam, sweeps over the work and checks it against the scaffold's rules. If it spots a mistake, bam, a red error signal flashes and gets sent right back to the agent. The agent then uses that super specific feedback to repair its work and immediately tries again. And it'll repeat that cycle over and over and over. And this loop just keeps on going until the artifact is flawless. The validator's scanning beam finally turns green. The artifact sails through all the final quality gates, and the finished, fully validated product is released. The job isn't just done, it's done correctly. Okay, so you might be thinking, why is this so much better than just asking an AI to write some code? The magic is in 4 specific mechanisms that are baked right into this architecture. First, the scaffold gives the agent an artifact grammar. Think of it like a really strict set of Lego instructions. It defines the exact shape and structure of what needs to be built, which dramatically cuts down on all the wrong ways the agent could build it. Second, correctness is externalized. The agent isn't grading its own homework. Objective, outside validators do that. Third, that constant repair loop turns errors from failures into incredibly useful targeted feedback. And finally, you've got a crystal clear division of labor. The scaffold is in charge of governance, and the inner agent is in charge of execution. And that's the key takeaway here. This isn't just some small adjustment. Traditional systems kind of just give a raw model some tools and hope for the best. Meta-Agentic Bootstrapping takes an already capable agent and embeds it inside a complete, rule-based world. It's the difference between giving someone a hammer versus putting them in a fully equipped workshop with a supervisor and a blueprint. So this brings us to what might be the biggest idea of all here. This pattern isn't just about building one system better. It's about building systems that can then build other systems. That whole structure we just walked through, the scaffold, the agent inside, the validation loop, that entire thing can become a single component. You can actually nest these meta-agents inside of each other, creating these incredible layers of governance and execution. This is what's called recursive composition, literally agents building and managing other agents. And that leads to this really powerful quote from the source paper. It completely reframes how we should think about AI development. The big question is no longer just what tools should we give this model. Instead, it's all about architecture. It's about designing the right kind of world with the right set of rules for the right kind of agent. Which, of course, leaves us with a final, pretty fascinating thought. This whole principle creates a pathway for AI systems to become exponentially more complex and capable, not by just making the base models bigger, but by composing them in smarter and smarter ways. So, if agents can truly start building, testing, and improving other agents, what does that unlock? Really, what comes next?